Today I'll be talking about how we built visual search products at Pinterest that are used by millions of people. So a one-line summary of what Pinterest is for those who don't know. Pinterest is a visual bookmarking tool that helps people save and discover creative ideas. So our users come to Pinterest to find recipes, to find ideas to decorate their house, and just in general to find inspiration. So a bit of history about visual search at Pinterest. The team was formed in 2014 when we acquired a computer vision company called Visual Graph. In 2015, we launched our first product, which was the visual cropper. So with this tool, you can search any part of any image on Pinterest for relevant recommendations to the query that you selected. In 2016, we released object detection in the same tool. And this was really to just help our users make the tool easier. So you don't always want to manually move a cropper. If you find objects, they're most likely the most interesting parts of the image. And we want our users to just be able to tap a button, or a dot in this case, to search over them. And in 2017, we released a suite of products starting from the visual extension, which is the visual cropper tool in a Chrome extension to bring the power of Pinterest visual search to any image on the web. We also released Shop the Look. So this is, given an image on Pinterest, there will be blue dots where you can tap on these dots to be able to buy the content in the image. So this is combining our visual search technology with human creation for quality. And lastly, we also launched Lens. Lens is our real-world visual discovery tool. You point your camera at a real-world object, and we'll give you recommendations for it. So when we look at the timeline, we can really segment this timeline to two parts. In the beginning, we were focused mostly on building the core fundamentals, the building blocks. Because at that time, deep learning was still new. We didn't have a retrieval system to do visual search over billions of images. So we just had to build that from scratch. So we didn't really focus too much on applications in those early years. But now we have those building blocks. And although we're still trying to improve it with better detectors, classifiers, retrieval systems, a lot of our time is actually focused on building applications using the technology to build products that consumers would love. So to go over some of the building blocks that we use classification. It's pretty much, I don't think it's a surprise. We use VGG, ResNet, ResNext. We use detection via the faster RCNN and single shot detection flavors. And we actually consider our retrieval system as a building block. So our retrieval system is, given an image, we search over billions of images, and we return to you other images. I'll explain more about why this is a building block later on. But first, how did we build this retrieval system? Well, at a high level, given a classification model, what you can do is extract, say for VGG, one of the intermediate layers, FC6, and you get 4,096 floats. You can binarize it, so the bit is 1 if the float value is greater than 0. Otherwise, the bit value is 0. And I won't explain why we do this. There's a paper that we released earlier this year that goes more in details on why this works, what model we use. But for now, just trust me that this can work. So with this, what you do during query time is, given two images, you extract these binary features, and then their Hamming distance corresponds somewhat loosely to semantics. So for similarity, we actually take the inverse of this Hamming distance. But basically, if images are close together in this Hamming distance, they usually are visually similar. So you do that computation for billions of images. Well, not really, because it's an approximate nearest neighbor. But you get pretty good results in general. Yeah. So retrieval is a building block because although it gives you images, it's actually also useful for derivative signals like annotations. So say that we have 2,000 visually similar images. On Pinterest, an image is really powerful. It's not just an image. It's a website. It has descriptions, keywords, et cetera. And we can aggregate all that information for example, into annotations. And this is really cool because unlike a classifier that has a fixed amount of annotations, for this, the annotations come from the data directly. And it's technically unbounded in terms of, well, it's bounded in the number of annotations in the Pinterest system. So I tried this sunflower or this flower clock example in our retrieval system, and I got like these annotations. One of the annotations, I guess it's like cut off here, but it's George Nelson. I had no idea who that was, and I did like a Pinterest search, also validated with the Google search. But it turns out that George Nelson seems to be like a company that creates these really cool modern furniture. And I wouldn't have known that ahead of time, but like the retrieval system was able to just generate this annotation from the data itself. Cool. So that's pretty much it for our building blocks. And now I'll talk more about the applications that we've built. So the idea with our applications is we have these building blocks, and stuff like the retrieval system is pretty powerful. How can we take these technology to build actual products that people would use? So I don't have time to explain all the different products that we've built, but I'll go into two case studies in Lens. So Lens is in beta mode, but what you can do is, again, is you can take out your phone, take a picture of an object in the real world, and get recommendations for it. So back during Lens Alpha, which is my code name for when we were brainstorming, we took an image of this avocado, passed it through our Lens API, and we got the avocado text and also thousands of images of avocados. So this is like it's a pretty good technology, as in it's able to recognize that this thing is an avocado, but it's super useless to us to give our consumers thousands of images of avocados. That's just not useful at all. So we thought, like, hey, this is not the product that we want to build. How can we use our building blocks to create something more interesting? So our Lens API is able to return annotations again from the classifier and also from these annotations derived from our retrieval system. And they have an associated confidence score with it. So what we can do is we can take these annotations and hit Pinterest image search, actually, to generate higher quality content. And this is great because we're building a product for Pinterest users, and image search at Pinterest has already been optimized to give content that Pinterest users would love. So here, if I search avocados, you don't get pictures of avocados. You get more diverse, interesting content. Like, I think over there is like a ham avocado recipe. There's like a avocado tuna salad recipe, and there's recipes for how you can use salmon and avocados together. So in Lens Beta, what we do, part of the stack is to have, if you're super confident about these annotations, one thing that we do is hit image search to get more interesting content. So another interesting example, another case study, is this thing we call object search. It's also a functionality in Lens. And the idea is that given this image of, say, like a chair, what we return is not visually similar chairs, but instead the entire room that contains this chair. So you can think of it as more useful because given like a chair I see in IKEA, I know that chair, like I know what that chair is because I can read a label. But I may not know how exactly to design a whole room with that chair. So how did we build it? So given our image corpus, we have billions of images. What we can do is we can run our detector through our image corpus. And this is really expensive, but we only do it once. And what you get is an object index. What you have is the cropped image from the detector output, and there's also an associate label with that cropped image. And given our retrieval system, given that we have a retrieval system, what we can do is we can do image search over these objects instead of the whole image. So given the chair, what you want to do is find the most visually similar object in our corpus. So here you get visually similar objects. They are just like the same chair. And then what you can do is you can always map the object back to the whole image. And that's how we get the scene for these home decor items. So overall, at Pinterest, the team is very product-driven. We can build the technology. We do optimizations for our classification models, our detectors. But we also make our decisions based off of feedback from the product. So what happens usually is we build a cool technology, we launch a product, we get user feedback, and then we use that information back into making more technology decisions.